Hey y'all! Today's objective is operations with radicals. So when I say radicals, I mean square roots. I'm going to show you multiplying and adding and subtracting. I think I might reference dividing, but it's really just going to be multiplying, adding, and subtracting today. So there's a few rules. To add or subtract, your radicals must be the same radicals and the same index, which means the little number on the outside. So if it's a square root, they both have to be like the square root of 5. Or they both have to be like the cubed root of 10. You can't have different radicals and different indexes when you're adding and subtracting. To multiply or divide, your index must be the same. So you could have the square root of 5 and the square root of 10 as long as your index is the same, the square. You could have the cubed root of 7 and the cubed root of negative 13 as long as the index is the same for multiplying and dividing. For adding and subtracting, they have to be exactly the same. And so when you're adding and subtracting, first you want to simplify. So if you have the square root of 24, you always want to simplify it when you're adding and subtracting. And you want to consider the radical as kind of like your x value. So if you have like 3 root 3 plus 6 root 3, your root 3 is kind of like your x value. So if you had 3x plus 6x, you would add that together and you would get 9x. Same thing here. You're going to add together your coefficients. 3 plus 6 is 9, and then you're still going to keep your root 3. So that is how you would add together. So when I say you're going to consider it as the x, you're going to consider it as a variable, and you're just going to keep that the same. All right, so here are some examples. In black is the problem written, and then I've just already shown you some of my work. So the first thing you want to do is you want to simplify, which is what the last lesson we did. So the square root of 8, I showed you over here upside down division. So the square root of 8 is really 2 root 2. See, 2 root 2. And then I multiply 3 times 2 and I get 6. Over here I did the square root of 32. And I got two pairs of 2. So 4 root 2. And then 4 times 6 is 24. Notice, by simplifying, I got the same radical and index. Square root of 2, square root of 2. So now I can subtract. 6 minus 24 is going to give me a negative 18 square root of 2. And that's your answer. When you do have operations with radicals and you're adding or subtracting, you have to have the same radical. So let's go over here to number 2. I have a variable in my problem. Alright, so to simplify 48, I've shown you my upside down division. So I have two pairs of 2, so 4 root 3a. And over here I had a pair of 3's, and so this would be 3 root 3a. Notice the goal is to have the same radical, 3a and 3a. My a's cannot come out because I only have one of them, and in order to come out of a square root, you have to have 2. So my a's stay under. I can add 4 plus 3 and I get 7 times root 3a. Okay? Alright, so number 3. Square root of 11 plus the square root of 99. Square root of 11 is a prime number. I can't simplify that anymore, so I need to work on the square root of 99. You can do a factor tree. I just choose to do upside down division. And I see I have a pair of 3's, so I know this is going to be 3 root 11, and this is root 11. Again, I need to have the same root. So in this problem, just like with another problem, if you had x plus 3x, when you add that together, you would get 4x. The same thing happens here. That's kind of like a 1. So if I'm adding together 1 root 11 plus 3 roots 11, I would get 4 times the square root of 11. Alright, so you try number 4. I want you to work it out. Either upside down division or factor tree. You have to simplify these. If you simplify them correctly, you should have the same square root, and then work it out. Alright, so 208. 2 would be 104. 2 would be 52, and I noticed 52, so I'm on the right track. 26, 13. So I have a pair of 2s, a pair of 2s. So 2 times 2 is 4, root 13. 52, I've already done it, so I can do it quickly. So that's going to be 2 root 13. Notice I have the same radical, the same root, and 4 plus 2 is 6, so this is going to be 6 root 13. Alright, I hope you got that one correct. So that was a little bit about adding and subtracting. Multiplying. Really, I'm just going to show you multiplying. Remember, your index has to be the same. The number under the radical doesn't matter as much, it just has to be the index. So on number 1, I've already done that one for you, and I showed you the cubed root of 25. We can't do the cubed root of 25, and we can't simplify the cubed root of 5, but when you multiply them together, you get 125. We can find the cubed root of 125, which is 5. All right. Number 2, you could multiply 48 times 30 and then simplify, but I'm going to suggest simplifying first. So let's simplify 48, and that's 2, 12, 6, and 3. So I have a pair of 2, so this is 4 root 3, because 2 times 2 is 4, and I have a 3 left over. 30. 2 is 15, 3 is 5. So that's as simple as it can get. We can't simplify 30 anymore, but at least I've gotten it down to I have a 3. So the numbers on the outside, your coefficients, you're going to multiply. So 4 times 3 is 12. And the numbers on the inside you're going to multiply. 3 times 30 is 90. But we're not done because it's not simplified. We need to see if we can break that 90 into something more simple. So I'm going to do 2 and I get 45. 3 is 15. Alright, so I've simplified those radicals a bit, and now I have a pair of 3's. So this is 3 root 10. I got the 10 because I multiplied 2 times 5. And now I have 2 numbers on the outside. So I can multiply 12 times 3, and I get 36 root 10. Alright, so that was a big problem. Now, if you want to multiply 48 times 30 and then simplify from there, go for it. I think it's easier to simplify 48, then you have 90, which is a little easier, it's manageable, instead of multiplying and then you're going to have something crazy. I don't know, some number in the 900s or 1,000. Okay? So number 3, let's throw some variables in the mix. So number 3, we have 2xy times 3, or the root of 2xy times 3 times the root of 6xy. Now, I looked to see if I can simplify, and I can't simplify the square root of 2, and I can't simplify 6. So I need to multiply. Again, this is like a 1, so 1 times 3 is 3. And now I multiply. 2 times 6 is 12. X times x. So remember, this is a 1 and a 1. And this is why you had to learn your your exponent rules. So that would be x squared, and y times y would be y squared. I can now simplify. So let's simplify. First, let's work on the 12. The 12 is going to be a pair of 2's can come out. So that's going to be 2 root 3. And then your x's. Since I have 2 of each, we did this earlier. Since I have 2, this is x, and this is y, and this is y. I can take those out of my radical because I have a pair of them. So when these come out, I'm going to multiply my 3 and my 2. 3 times 2 is 6. My x comes out, my y comes out, and then I'm left with my square root of 3. Alright? That's a lot. So 4 and 5. so number 4. I have 2 and I have 10. I can't simplify 2, and 10 is 2 times 5, so nothing's going to come out. So I need to multiply. My 2 times 2 is going to give me 4. And then I'm going to multiply. 2 times 10 is 20. X, there's no other x's. Y times y is y squared. And then there's z. I hope you can see that. I'm going to change markers. When I look at it, I can see that my y is going to come out of the radical because there's y squared. My x and my z must stay underneath because there's only one of those. There's one x and one z. But now let's look at 20. I need to simplify 20 to take 20 out. I have a pair of 2s. So 20 is the same thing as 2 root 5. I can multiply my 4 and my 2. So that's going to give me 8. But remember, my y is coming out, so 8y. And then I have left 5. And then my x and my z. Okay? I know some of you might be like, oh my goodness, I don't know what I'm doing. And some of you are following it. We're going to practice, but this is not easy. Alright, so number 5, we have 6xy and 10y. I'm going to multiply my 2 times 3. That's going to give me 6. 6 times 10 is 60. X times nothing over here, so it's going to be x. And y times y is y squared. So from this point here, I want you to see if you can do the rest. You have to figure out, simplify 60, either by a factor tree or upside down division. And then you have to figure out which variable can come out of the radical, the x or the y. And we'll go over this in class.